Section 2 of this chapter deals with the unit circle. Now, yes, I'm afraid you're going to have to get this memorized, and I would do that as soon as possible. Main thing with the unit circle is, well, it's a unit because its radius is 1. It goes out from the origin, put it on a regular xy axis, 1, 0, 0, 1, negative 1, 0, 0, negative 1. So what this allows you to do, if you know it well, is to generate a lot of values off of it. Okay? Because your main trig functions, if your radius is 1, will follow. Your sine of t is always going to be the vertical, how far up from the x-axis you are, or down from the x-axis you are. Cosine is always going to be the horizontal, how far out you are from the y. Tangent is going to be that ratio of y over x. Cosecant's the inverse of sine, secant's the inverse of cosine, cotangent's the inverse of tangent. Everybody should be familiar. So, if I want to evaluate the 6 trig functions at each real number, okay? So, for this, I'm actually going to set these up a little bit. If I'm going to do the 6 trig functions, that's sine, cosine, tangent, cosecant, secant, and cotangent. So when they're asking for all 6 trig, that's what they're referring to. So sine of the angle t, if it's 2 pi over 3, well, I'm going to go to the unit circle. 2 pi over 3 is in the second quadrant right here. It's not splitting the difference right in the dead center, so it's not going to be square root of 2 over 2 and square root of 2 over 2. It's going to be the other two, 1/2 and square root of 3 over 2. Now, because I can see it's closer to the x, the smaller one is going to be on the x, the larger one on the y. And that's the way I keep track of them. I know the sets are going to be square root of 2 over 2, square root of 2 over 2, 1/2 and square root of 3 over 2. So, because this distance here on the x is shorter than this distance on the y, I just put that first in the x. Now, because we're in the second quadrant, though, the x has to be negative. So then I can just kind of run down the list. I do need to simplify these a little bit and mess with them, but sine is just going to be your y value. So square root of 3 over 2. Cosine is going to be your x value, or negative 1/2. Tangent is going to be what you get when you divide those two. Now you got to do a little bit of work for that, but I'm going to take square root of 3 over 2 divided by negative 1/2. Now if I'm dividing by negative 1/2, though, in reality I multiply by its reciprocal. So I'm multiplying by negative 2 over 1. The nice thing here is the 2's go away. You're left with negative square root of 3. Okay, so tangent of t is negative square root of 3 in the second quadrant. Cosecant, the nice thing there is you can just flip them. 2 over the square root of 3. But wait, can you have square roots in the bottom? Nope. So I'm going to multiply this times square root of 3 over square root of 3. That's going to yield 2 root 3 over 3. And that's your cosecant for that. Secant, that's the nice one. You can just flip over negative 1/2. And cotangent, you're just going to flip over negative square root of 3. But again, you can't have square root on the bottom by itself, so multiply by square root of 3 over square root of 3. You get negative square root of 3 over 3. Okay. How quickly you can do those, practice them. That's the biggest thing. Practice them. You get easy ones like 2 pi. I'm going to skip the 4 pi over 3 for now. That's primarily just negative signs, watching those. If you want to take a moment and do those, that might be a good thing. For 2 pi, if I do run through the same process, sine of 2 pi, well, 2 pi is right there, coordinates of which are 1, 0. So sine of that 2 pi is just going to be 0. Cosine is 1. Tangent, since it's sine over cosine, it's 0 over 1, which is just 0. Cosecant, for cosecant, that one's going to be 1 over sine, or in other words, 1 over 0. Well, I have a slight issue here. There is no cosecant for 2 pi. Cosine, 1 over 1. Hey, nice thing there is still 1. And tangent, or cotangent, I should have said, of t is going to be 1 over 0 again, which is also non-existent. Same type of thing happens at pi over 2. You just run into that with cosine, or I'm sorry, with secant and tangent instead of cosecant and cotangent. Okay. Those should be familiar enough. Now, when you have a negative angle, you got to think about it a little bit first. Usually what I'll do is I'll find the coterminal for that and convert it. So the idea is I'm going to move this, I'm going to add to it 2 pi. Now, when I add 2 pi, I'm actually going to add 2 pi converted so it's over 3. Well, that's going to be 6 pi over 3. So when I do that, that gives me 4 pi over 3. So if I do all those for 4 pi over 3, it's going to give me the same angle result as negative 2 pi over 3 would have. So when I go about this, I'm going to have sine of t. Well, again, 4 pi over 3 is going to be down here closer, because the nice thing is all the 3's over 3's are going to be closer on the x. But using your unit circle, you can take a look at that. For now, you end up here. Well, this x value then is going to be the smaller of which, so again, it's 1/2. The y value is going to be the larger of which, so it's square root of 3 over 2. And since we're in the third quadrant, actually, they're both going to be negative. Okay, so when I do sine, it's negative square root of 3 over 2. Cosine is negative 1/2. Tangent is going to be, because it's negative over a negative, square root of 3 over 2 times the reciprocal, 2 over 1, gives you square root of 3. Cosecant is going to give you the reciprocal again, so negative 2 over the square root of 3, except, again, you can't keep it that way, so negative square root of 3 over 3. Secant, I'm just going to go over here with it. Secant is that inverse of cosine, so that's just going to be negative 2. And lastly, cotangent is going to be the reciprocal of tangent, so that's 1 over the square root of 3. In other words, square root of 3 over 3. And yes, you do need to give me square root of 3 over 3. I will not take 1 over square root of 3 because the answer is not simplified. Some domain issues that come up a little bit, just for a review here. Because these are periodic, they repeat. Okay, so the periodic function, the idea is there is some value c that if you add it, nothing changes, which for sine and cosine is just going to be adding 1 rotation. In other words, add 2 pi. Tangent's a little bit different though, because it starts to repeat a little more often. That one's just going to be adding pi. Okay, and that's true for all their reciprocals as well. As far as the even and odd goes, well, if you think about your graphs for a second, I'm just going to review those. All these properties are in the front of your book, those ones you need to memorize for chapter 5. But if I look at cosine, cosine's even because it starts up here and goes down. Well, it also goes this way. So you can see it's symmetric over the y-axis. So cosine is even. Sine, though, is odd because it hits at the origin and then goes up. You can actually see it has that rotational symmetry for sine. So that's why sine is going to behave in the, as an odd, and cosine will behave as an even. The reciprocals will also match up. Cosine and secant are both even. Sine and cosecant are both odd. Tangent and cotangent, we'll get into those later, but those are also odd. So you can swap out values as needed to compensate. Okay, a couple more. So if I want to find the following, I want to convert these so they actually show up on the unit circle if at all possible. So if I do cosine of 9 pi over 3, for cosine of 9 pi over 3, I'm going to convert that. Well, first off, it's cosine of 3 pi. 9 pi over 3 simplifies. And then I'm going to subtract a rotation to get back to cosine of pi. Just subtract 2 pi from 3 pi, you get cosine of pi. Think about your unit circle. Pi is right over here. Cosine at that value is going to be negative 1. Negative 11 pi over 2, you actually want to add some rotation since it's negative. I'm going to add these a few different times, figure out where it lands. Now, I'm going to add 4 pi over 2. When I do that, that's going to give me negative 7 pi over 2. Well, I'm still negative, so I'm going to add another 4 pi over 2. That's going to get me to negative 3 pi over 2. And again, I'm still not there yet, so I'm going to add one more 4 pi over 2, giving me pi over 2. Those are all coterminal angles, since they're all 2 pi away from each other. So what this really means is, instead of doing sine of negative 11 pi over 2, I can just do sine of pi over 2. Again, look at your unit circle. This would be up at the top. Sine up at the top there is going to be 1. Okay, looking at the even and odd stuff, tangent was odd. So if I'm doing tangent of negative t, it's going to follow those odd properties where it's equal to negative tangent of t. And if I know tangent of t is 2/3, that means this is going to be negative 2/3. Okay, one more. So if I want to use a calculator to evaluate these, punch them in, it's going to give you a decimal. Now for these, I do want you to round to 4 decimals. Even if the book's asking for 3, I want you to do consistently 4 because those actually go back longer than what this book does. Just stick to 4 decimals for it. If you punch that into a calculator, make sure real quick when you do it that you get 7.7818, just to make sure all the settings in your calculator are right. These will want to be in radians. Now the bad part about the next one is cosecant is not a button that's given to you on your calculator, so you do need to adjust it a little bit. Instead of doing cosecant of 2, that's going to be the same as its reciprocal. In other words, 1 over sine of 2. Okay, using that reciprocal property. If you punch 1 over sine 2 into the calculator, or you could actually do it this way as well, that's going to be 0.9093, just so you can see it. Type the whole thing in, that's fine. It'll give you 1.0998. Okay. Since you're using a calculator to evaluate, that would be the answer you want to give. Okay, these first 2 sections aren't too bad. I'll be back tomorrow, then we'll get back into the right triangle trig. In other words, good old SOHCAHTOA. See you tomorrow.